Hello everyone! In this video we're tackling key concepts from the functions topic in our IB Math AI SL and HO. And in today's video you'll learn how to interpret graphs, use your GDC effectively, and solve some tricky exam style problems. And this will be all explained step by step. So let's get started. Problem 1. A relation is defined as the set of ordered pairs, and we are given 5 pairs 1, 2, 2, 3, 3, 4, 4, 3, 2, 5. And is this relation the function? Explain why or why not. And firstly, you have to know that our first place always corresponds to x, and second place always corresponds to y. And now you can observe that our y's are here the same, and our x's are here the same. And now we can answer our question if this set of ordered pairs, if this is a function. And when we have the same y's, it can be a function. However, when we have the same x's, it cannot be a function. So you have to remember that if we, here we underlined our x, which is the same because it's 2 in both pairs, so it means that that's not a function. We can write our answer like this: not a function, because a relation is a function only if each x value corresponds to one y value. Problem 2. Given fx equals to x squared minus 3x plus 1, express fa plus h minus fa and simplify as much as possible. So in this problem, we just need to substitute firstly a plus h into x in here and in here, and then subtract this function with a as substituted as x. So we can write our function like this, and now we have to be careful because here we have x squared. So firstly 2, then our x, this x is this whole expression. So a plus h squared, then minus 3, and x, so a plus h and plus 1 after the bracket, and in here 2a squared minus 3a plus 1. And now we need to simplify it. So it looks like this for now. And now we can just subtract from our first function our second function. So it will be 2a squared plus 4ah plus 2h squared minus 3a minus 3h plus 1. And then we have to remember that this is our fa. So this is the whole expression. So we have to write it in a bracket. We can also write a bracket in here, but it doesn't matter. However, the second expression has to be in a bracket, because we will change our sign, because in here we have minus. So in bracket we write 2a squared minus 3a plus 1. And now we have to remember that this whole expression will change its sign. So in here 2a squared now is negative 2a squared. Our negative 3a is now positive 3a, and plus 1 is negative 1. And now we can see that here 1 positive and negative 1 will cancel out. Also 2a squared positive and negative will cancel out. The same as with negative 3a and positive 3a. So our final expression is 4ah plus 2h squared and minus 3h. Problem 3, the function g, and we have square root of 5 minus 2x is given. And we have to find the domain of our function g and the range. In order to find the domain of g, we have to keep in mind that our expression, when we have square root or any root, has to be equal to 0 or greater. So our 5 minus 2x has to be greater or equal to 0. So in other words, everything what is under root cannot be negative. So we have something like this. Now we have to move negative 2x to the right hand side. So we have to change its sign. So here we have 5 and now we have 2x. Then to find x, we need to divide both sides by 2. So here we have 5 divided by 2, so it's a fraction. And here we have just x. And this is our answer. However, we can also write it in this form. So x is smaller, is the same or smaller than 5 over 2. So from minus infinity to 5 over 2. So this is our domain, and now we have to find the range. And in order to find range, we just need to simply substitute firstly minus infinity and then 5 over 2 to our function g, and we will find our range. So we can start maybe with 5 over 2 because it's a real number, so g of 5 over 2, and we know that it will be equal to 0, and here times 5 over 2. So we have 5, this will cancel out, minus 5, so it's square root of 0, so this is 0, and g, and now we have minus infinity. So we have to remember, maybe it's not that obvious because we cannot simply substitute minus infinity into our x, but we have to think logically that if we have very small number, so our very small number times minus 2 will be a huge number, so it will be probably plus infinity. So 5 plus a very huge number, so 5 plus infinity is infinity, and square root of infinity is infinity, so it will be infinity. And now we can observe that infinity is obviously greater than 0. So we can write our range like this, from 0 to infinity. Problem 4. The graph of y equals fx passes through the point 2, 3. Describe the coordinates of the corresponding point on the graph of. And we are given two functions. In point A, we have y equals fx minus 1 plus 4. So everything what is in bracket So here, this corresponds to our 2, so to our x. And everything what is out of our bracket, so in our case 4, is connected to y, so to the whole function, so this corresponds to our 3. And we have this transformation on x. And you have to keep in mind, because it's very important, that if we have x minus something, we move our x to the right. So our starting point, so 2, because we are only working on x for now, this is 2 plus 1, so our new x is 3. So it's very important to be not confused by this sign, because if we have x minus something, our new point is our x plus something. Okay, so this is our new x, and then we have y, so our starting y is 3, and here we do it as our sign shows, so just 3 plus 4, and this is just 7. So our new point is 3x and 7y. In B, we have something different, because in A, we had horizontal shift and vertical shift, and now we have something called compression and reflection. So we can observe that firstly we work with x, so here we have 3x. So with x's is always something reversed, because as you can observe in our point A, we had minus, however we added 1 to our starting x. Now we have 3x, but it means that we compress by factor 1 over 3, so 1/3. So not 3, but 1 over 3. So our starting point x is 2, and now we have to compress it with factor 1 over 3, so just multiply it with 1 over 3, so this is 2 over 3. So this is our new x, and now we have with y we have minus 2f, and this means firstly, if we have minus in front of f, it means that this is vertical reflection, and 2 in front of f means that we have to stretch our f by this factor, so by 2. So in other words, we just simply need to multiply our 3 from our starting point times minus 2, and this is minus 6. So our new point is 2 over 3 and minus 6. Problem 5, given the function f(x) equals 3x minus 5 over 2, and in point A we have to find the inverse function. And if you watched my videos from number and algebra chapter, we already solved this kind of problem. However, now we will do the same, so we have to find the inverse function. And as you remember, in inverse function, our f, so our y, because f in function is the same as y, is swapped with x. So here we have f, here we have x, And in our inverse function, this is the same as x, we can say, and this is the same as f, because if we have, for example, f in here, and we can substitute 1 into x, if we want to find inverse of this, our f to the power of -1 will be 1. So this works like this. So our y has to be swapped with x. So I rewrote our function from command with y, and now we have to swap our y with x. So x equals 3y minus 5 over 2. And in order to find inverse function, we have to just designate our y. So first thing that we can do is, of course, multiplication. So we can multiply it by 2. So we have 2x equals 3y minus 5. Now we can add 5 to both sides. So we have 2x plus 5 equals 3y. And the last thing is division, so we can divide both sides by 3. So we have 2x plus 5 over 3 equals y. So we can rewrite it like this. F to the power of -1, x equals 2x plus 5 over 3. And this is our inverse function. In B, we have to verify that f of our inverse function x equals x. So this is our inverse function. So we can simply substitute what we found in here. So f, and here we have 2x plus 5 over 3. And this works as x. So to our initial function, fx equals 3x minus 5 over 2, we have to substitute this into x. So we have 3x. So x is 2x plus 5 over 3. Then we have minus 5 in our initial function. And here we have 2 in denominator. And now we have to simplify it. However, we can observe that here we have 3, so they will cancel out. And we are left with 2x plus 5 minus 5 over 2. So they will cancel out because we have positive and negative 5. And here we have 2x over 2. And 2's will also cancel out. So our answer is x, as we needed to verify. And when we have the situation like this, we have our function and inverse function, this is always equal to x. And that's all for today from this functions topic. If you found this video helpful and useful, please leave thumbs up, subscribe to my channel, and if you have any questions, feel free to reach me out in comments down below or via my mail that is in the description of this video. See you!